Now we'll see another topic is called finite automata. FA is now a finite automata or finite state machine to the regular grammar. How to convert that FA to grammar? So it is very simple one. There is some procedure is there. We need to follow that. So theorem is like that. Every language, regular language, can be generated by regular grammar. Definitely every language can be generated by regular grammar. So similarly, every regular grammar generates the regular language. Definitely every regular language can be generated by regular grammar. Definitely can generate it, and every regular grammar generate the regular language. Is it possible? So his question is like that. What do you do? Is every language a context-free grammar, a context-free language? Absolutely right. Is every language a context-free language? Definitely have to check it. So if is it a language, every language generated by regular grammar is a context-free language, or every regular grammar generates the regular language, definitely is a context-free language. Now, if that is keep in mind, let us move to the NFA, epsilon NFA to CFG, right? How do you convert that? First of all, name all the state in the NFA by a symbol. So you have to call start state S. Then for each edge, you have to write it like this. So what is a corresponding grammar? What is a corresponding grammar? X gives, what is the symbol is a transition from X to Y on A. A can write it. Where it will go? It will go to the Y. So you have to write it like that. Write like this. For each edge, you have to write a corresponding grammar. This is a state diagram. You have to write the corresponding. So what about this? For each edge, what will be the X gives Y. Why? X gives Y. So there is even epsilon if you write, nothing will give, so it is a XY. Right. So now you take a, for each edge of like this, what will be the corresponding grammar? A, X, it will go to the same state. Write it like that. Write a X. Then for each final state, X should write. So for any final state, it will be like this. There is a one more rule has to come, epsilon. This will be the epsilon. Now look at this. This is a grammar I have taken here. What is S? S is go to the AS only. Then S gives BX. Then S gives BY. So up to this is S. There are three rules are generating, three edges from S. Then X. X has only one edge, right? X gives BY. BY. Then Y has only one edge. Y gives AY. Then why they are writing 2 epsilon is here, since they are final state. X is final state, simply adding one more rule, X gives epsilon and Y gives epsilon, since both of them are final state. Understood now? Now we have to write a grammar. I have taken one of the state diagram. So it will go to the A only. What is the grammar is generating here? A gives A0. 0A, sorry. So now we have one more edges going from A, then A gives 1E, 1B. Then what is the one more rule has come from, one more edge has from B to C, then B gives 0C, right? Then we'll see. We have one more edge from B, then on 1, we'll go to the same state now, B, 1B, right? Now, so C, will come to C. C has a edge from C to A. Then you have to write as C gives 0A. Then C also goes to B. Then you have to write C gives 1B. Right. Then which is the final state here? C. C gives epsilon. So C gives epsilon. Right. I am writing here. At last, all the incoming transition to the accepting states are designated by production, source state and input symbol. So he has written as like that. So very simple one for writing it, right? Now, exercise for you people. You should write a regular grammar for this diagram. Okay, I'll should have to practice it, and also will be take up this in the live classes. I'll do it on the blackboard in detail. So